day of the Open Symposium. And today is the day we're going to discuss dark matter, cosmology, and gravitation. And as usual, we're using the Slack channel, which is actually called Dark Matter, Cosmology, and Gravitation for messages. There's a sign up sheet that I put the link there, just to have an idea of people that are attending. And the chair will be Jorge Molina. So I pass the word to Jorge to chair the session. Thank you, Jorge.
Hey, thank you, Rogerio. Well, it's a pleasure for me to be the chair of this very important topic, that is dark matter. So we'll start with Diana Lopez from UBA, University of Buenos Aires. So please, Diana, if you can start.
Thank you, Jorge, and thank you all of you that are connected. So I'm a member of the preparatory group of the cosmology section. So to put in context the contributions of the section, let me start with this pictorial representation of the evolution of the universe. So the redshift on the bottom set equals to 0, it corresponds to the present, and it decreases toward the past. And in the standard cosmology, the evolution is described starting from initial background homogeneous universe with small density perturbations. And to do this, standard assumptions are used, such as the validity of general relativity, GR, and standard physical laws. And thanks to observations such as the background acoustic, the cosmic background radiation, the CMB, we have a standard cosmological model. The model has a few parameters. The base one has only 6 that can be inferred from different observations. This one, H0, tells us the current expansion rate of the universe. And given this, the first parameter tells us the amount of ordinary matter, which turns out to be only the 5% of the energy budget of the universe. So the success of the model requires the existence of additional matter, it's called dark matter, with a relative abundance given by the second parameter. And there is no fundamental particle inside the standard model of particle physics associated to this dark matter. So to explain this, we need new physics. The rest of the budget is also a mysterious component that is described with this constant lambda, and generically as a dark energy. And thanks to many observations, not only on cosmological scales, but also on astrophysical scales, since the dark components have gravitational interactions, it has been possible to infer some of their properties. However, we don't know their nature, and so far there has been no detection of non-gravitational interactions. And the third parameter, this theta MC, is connected to the fact that before redshift 1100, this epoch, the photons of the CMB were strongly coupled with the baryons that make up the ordinary matter, while dark matter were not. So this gives us an important distance scale that is called the baryon acoustic oscillation scale, the BAO, which is imprinted not only on the statistical properties of the CMB, but also on that of matter. Finally, the last two parameters characterize the distribution of the initial perturbation, and data is consistent with having initial Gaussian distribution of only adiabatic density perturbations. But still, the origin of the primordial perturbations is not understood. And remarkable, there are results in apparent contradiction with the standard model, mainly for this H0. The same parameter H0 can be measured with observables involving local or direct observations in the latent universe, such as supernovae or strong lensing. And the results are values that are larger than this, and the discrepancy is now between 4 and 5 sigmas, so there is a tension. So from the observational perspective, this highlights the importance of having different proofs, studying cross correlations between the different observables. And indeed, there are surveys observing galaxies at different frequencies taking their spectrum, creating catalogs with different properties. And the advantage of these surveys is that they can obtain three-dimensional information of the matter distribution. For instance, current data from stage 3 spectroscopic surveys, such as BOS, already provide constraints of comparable precision of those obtained from the CMB in an independent way for some parameters. Another example is the measurements of the absorption lines in the spectrum of distant objects due to the neutron hydrogen that is in between, such as the Lyman alpha forest. And the BAO scale I mentioned before has been measured not only with the CMB, but also with this kind of surveys. And there are other properties that can be used, but time goes fast, I will not go into the details. And there are new windows. Recently, radio surveys are starting implementing a technique called intensity mapping. This takes the integrating radio emission from unresolved gas clouds and uses the redshifted 21 centimeter line of the neutral hydrogen gas as a tracer of the distribution of the large scale structure. But they are also detecting some mysterious fast radium bursts, which are maybe useful also for cosmology or for some discovery. Another window arose with the detection of the gravitational waves together with the coincident gamma ray burns and other electromagnetic signals associated to the binary, to the valences of a binary of two neutron stars. And these measurements allow to constrain the speed of the gravitational wave to such a level that many alternative models of the dark sector were ruled out. So now, if more binaries of these kinds were observed, say 50, it will be possible to use this technique to measure H naught with similar errors as traditional methods. However, so far, the most frequently detected events are associated to binary of two black holes. But these measurements provide several tests of general relativity, alternative models, and well, black hole catalogs are maybe also useful for cosmology. And well, the existence of gravitational waves is a prediction of GR, and most of the models that explain the origin of the primordial density perturbations also generate primordial gravitational waves. And these relics could be observed in the polarization of the CMB. And this will give us information about this very early epoch. So from the theoretical perspective, the current status highlights the need of analyzing data to obtain physical quantities, test robustness, and understanding the data and how they are analyzed. Theoretical work is also needed to explore connections of the results from cosmological, astrophysical, and laboratory experiments to study alternative theories, their consistency, robustness, connections with particle physics and with fundamental physics laws, and to evaluate the validity of the standard assumptions, and so on. So all I have said is it's very hard. And more from Latin America, where with a sparse community of hours, where mobility is difficult. So I think it's crucial to join forces and different expertise. For this also, large local research infrastructures that involve different expertise and together with mobility programs can make a big difference. So to sum up, I identified the following size drivers of the community that can be summarized in the following questions. So what are the nature and the properties and origin of the dark components? What's that matter? What's lambda? Do they have non-gravitational interaction? what's the origin of matter and antimatter asymmetry. So as Carlos Wagner explained on Monday, we don't understand the origin of this 5% either. And also, as part of matter, we have neutrinos, and cosmological data is sensitive to the total mass of the neutrinos. So another question that is relevant for the community is, what are the nature and properties of neutrinos? What are the nature and properties of black holes? What are the origin and the nature of the primordial perturbation? Are they no Gaussian? How many degrees of freedom? Are there primordial gravitational waves? And finally, when are the assumptions, the standard assumptions wrong? Some modification of gravity, Lorentz violation, non-standard thermal or non-thermal history. So given this science driver, this is my overview of the received contributions. So let me start with LSST. LSST is an NSF-founded wide-field telescope in Chile, which is a photometric survey that will measure billions of galaxies and stars and generate a lot of data. It is due to start in 2 years and last about 10 years. And in this timeline, there are other important surveys that are complementary, such as the ESA satellite, Euclid, and DESI in US, which will also take the spectrum, but they are complementary. But the main science driver is to explore the nature of the dark sector and to test the standard assumptions. To address these questions from Brazil, in this context, according to the white paper, there are currently 9 PIs and 19 juniors that are members of LST, and they are analyzing different observational quantities in the Bayesian framework for different catalogs. And the main challenge is to have access to data and a big amount of data. So the other contribution is from QUBIC, which is a unique instrument. It is a spectrometer, which will measure the polarization of the CMB from Argentina in a place next to JAMA. JAMA is a common project of Argentina and Brazil, and we will hear more about this on Friday. I shall say that recently I have received the information that JAMA is aiming to contribute to the cosmological science goals, and I hope to hear more about this. But QUBIC is a collaboration that also involves non-Latin American countries. It's an international collaboration, and the main science driver is to explore the existence of gravitational waves. And to put the experiment in context, I copied this table from the white paper with the forecast for R. R is a parameter that measures the relative strength of the primordial gravitational waves with respect to the density perturbations. The current bound is 0.06. And in this table, there are other ground-based experiments, all mainly US-founded and in Chile or in the South Pole, and they are complementary. One particularity of QUBIC is that it is good at controlling systematic error. Also, in this forecast, they have only 2 frequencies, but being a spectrometer, they can probably use more, which is good for removing foregrounds. So in the white paper from Argentina, there are about 22 members, but I heard that they are more now, and they are working on simulations, data analysis, mounting the experiment, doing infrastructure inside. The target for QUBIC is 0.01 for R in 2 years with only 1 module, which is about to be ready. And in the future, more modules at additional frequencies could be added. So another contribution was from Bingo, which is a radio telescope to be built in Brazil, designed to measure the baryon acoustic oscillation scale imprinted in the neutral hydrogen gas present at low ratio. The main size driver concern the nature of the dark sector and the standard assumptions, and they will use the intensity mapping technique. The main challenge is are the galactic and extragalactic foregrounds that are factors 10 to the 4th larger than the signal. And it can be seen as a ground for testing the potentiality of the technique and as a pathfinder for future much bigger experiments such as SKA, and also as complementary to ongoing experiments like as the CHIME, which is a Canadian experiment, and the Chinese timeline that optimize for larger redshifts. So most of the members and founding agencies and institutions are from Brazil, and the experiment is under design and to be built also in Brazil. So the next contribution is the SAGO proposal. The final goal is to have a 3rd generation laser interferometer for gravitational wave detection observations in South America. So in this plot, these lines are projected sensitivity curves for the 3rd generation and 2nd generation telescopes, and the one for lower frequencies is the laser space mission. So the main size driver is of course to understand the nature and properties of black holes and the dark sector, and also to test the standard assumptions. The methodology is to go step by step. I copied this from the white paper. So the first step would be to build a local community with enough expertise in experimental activities and data analysis, and to involve Latin American students and postdocs in the project process, such as LIGO, Virgo, KAGA, LIGO India, and the more future projects, such as the 3rd generation one, the Einstein Telescope and Cosmic Explorer. And what they found very challenging is to attract them and foreign researchers with knowledge on 3rd generation detectors to shape research groups in Latin America. And this is challenging. The main challenge is that only a few Latin American researchers are involved now in laser interferometer projects. According to the white paper, there are about 12 researchers. The next one is a proposal of a new site, a new astronomical site in Macon Ridge in Salta in Argentina. The main size driver are explore the nature and the properties of the dark sector and a possible modification of gravity, Lorentz variolation. And this is in the context of gravitational waves and multi-measure astronomy. The methodology is to develop the site starting with 2 complementary projects, the ABRAS and the TOROS project, dedicated to the electromagnetic counterparts of gravitational wave events in the near infrared and optical range. And they will focus mainly on binary neutron stars transient events. Most of the members are from Latin America, including Argentina, Brazil, Chile, and Mexico. And now this is a common project in Argentina and Brazil. And finally, we have the proposal of a Latin American graduate school. The main science drivers are all listed. And the context is the fact that theoretical work is needed and access to data too. And for this is crucial to join forces and different expertise. As for the methodology, I copied this from the white paper. It is to increase the amount of human resources, which is an important part of research infrastructures, dedicated to theoretical aspects of astrophysics and cosmology, and to the use of the astronomical facilities installed in Latin America. to promote the integration of the Latin American community working in astrophysics and cosmology. And for this, they propose to use the PPGCosmo experience. I hope to hear more about that after the talk. And the proposal is to have a wide range of thematic areas and mobility. Okay, thanks. That's all. Now Diego will tell you more about the other contributions.
So in fact, I am Diego Restrepo from Colombia. I'm going to motivate the presentation of the white papers related with dark matter. There will be two from theoretical and experimental activities in Brazil and another about experimental activities in Argentina. The next one, thank you. In the first parts by Diana, we already saw the gravitational evidence motivation for the existence of the dark matter. And in the talk by Carlos Wagner, we already saw the example of the dark matter candidate in supersymmetry corresponding to one weak interacting massive particle. However, this kind of window is now very explored. And for example, in the near future, in experiments like DARCSide that will have participation from Brazil, the full parameter space is basically covered until the neutrino floor. So now the wind paradigm the wind paradigm is already explored, is motivating the exploration of other dark matter possibilities in other ranges of masses. And we can see that, in fact, we have a lot of parameter space to explore. Maybe another way that is having one strong activity is the QCD axion window. But between them, between the QCD axion window and the WIP axion window, we have the so-called light dark matter possibilities. These light matter possibilities need to have new experimental ideas and new experimental techniques with the current detectors. We will focus in this region, and in fact, this region is very interesting because have a strong interaction with neutrino physics and dark sectors like vector mediators. The next, please. The dark matter can be searched in different ways. One of them is indirect detection that is done by searching the fluxes produced by stable particles with high concentration in the universe, for example, in the center of the galaxies. In this kind of signal, we try to see the effects of dark matter annihilation or decays. In the white paper presented later, we will see the Brazilian involvement, for example, in CTA that will explore gamma rays, especially from very energetic sources. In the case of that matter, it is especially well suited to a study model with high mass dark matter candidates. For example, in the plot there, we see the case of the so-called large mass solution of the inner Higgs doublet model. This analysis done by Farinaldo and Carlos Laguna show that CTAs, for example, will exclude basically all the available parameter space in this model. Brazil is also involved in AMS, in the AMS experiments in the... There is some noise. Okay. In the AMS experiments in the International Space Stations that is looking for antiparticles coming from the universe. And all this is basically complemented with further gravitational evidence, like the ones explained by Diana, like bingo experiment. That also obviously have participation from Brazil because it's one Brazil experiment. Another way to search for that matter is from colliders. Basically there, people try to search for missing transverse energy signals at the LHC and also for long-lived particles. Latin America is involved in a lot of experiments, basically enough of them. And the important one for that matter searches are CMS, Atlas, LHCb's, for example, for long-lived particles. And also, obviously, Latin America is also participating in the discussion about future colliders. The next one. So, when we try to explore the low mass dark matter window, we need to consider the effects of neutrino interaction. For example, for masses below 10 GeV, we have the so-called neutrino floor that comes from the coherent neutrino interaction in the detector from neutrinos coming from the sun. In this kind of interactions, not only the background generated is important, but also possible new physics contribution. For example, see there is some extra boson there, the effects of the neutrino of interaction can be magnified by several order of magnitudes and interfere with the expected signal from dark matter. So it is very important to correlate this kind of experiments with neutrino experiment to disentangle the real signal. For example, now with the excess in the xenon one-ton experiment, we have this problem that we cannot say if this is just a no background or neutrino physics related or dark matter related. The next one, please. So one of the possibilities of the mediator is spin-1 gauge bosons that couples strongly to dark matter, but couples only weakly to charged standard model particles. In general, this kind of vector mediator are called dark photons. This kind of dark photons can be directly produced by the same proton beams that produce the neutrino beams. For example, from the direct kinds of the pions to them. But also they can be produced in the near detector, for example, by the neutrino beam itself, like in the second plot in the lower left part. Also, this kind of vector mediator can mediate interaction of the action with the dark matter detectors and produce signals. And finally, the dark photon can be the dark matter itself. If it is the lightest particle in the dark sector. And this is shown in the right plot from a very recent analysis where this kind of model is used to explain the current excess of xenon one-ton. And for example, the excess is very well suited in the available parameter space. And this kind of scenarios have no problems to explain this kind of signals. However, we are still interested even in lower masses. The next, please. To cover even lower masses, we need to change the technology. One of the prominent ones is the ones based in silicon detectors. And in particular, Argentina is participating in the Sensei experiment that have recently released its later results about these kind of searches. The next one. So these direct detection techniques involve the same technology that one explained yesterday for coherent elastic scattering by CONI with one stroke that is one strong experiment in Latin America. The same techniques is now using for the detection of direct detection of dark matter, and in particular will be presented one white paper about a laboratory in Argentina about this technology. And finally, we see here participation from Brazil and Argentina mainly, and in Colombia, the next one. There is one strong theoretical activity, but the community is very aware of the necessity to get more involved in experimental possibilities. So we are very open to see what is happening here. Thank you.
Okay, thank you, Diego. So we'll go to any questions now before going to the next speaker. Please raise your hands.
Okay.
Okay, so if there's no question, let's go to the presentation by Julio Fabris about the Latin American Graduate School. Please, Julio, you can go ahead.
Okay, thank you, Jorge. I'd like to talk a little about the PPGCosmo experience and the possibility to construct a Latin American graduate school, as Diana has already evoked. So this presentation is collaboration with Herman Velting. And what is PPGCosmo? Okay, let's try to describe. How can I make here? How can I pass for the other one?
Okay, so Diana will pass this slide.
Okay. So it's the name PPGCosmo is acronym for Programa de Pós-Graduação em Astrofísica, Cosmologia e Gravitação. And it has been created in 2016. And one aspect of this creation is that when it was created, it has received evaluation 5 in a scale that goes to 0 to 7, that it was a very unique event because it's the first physical program that has received this. In general, the physical program receiving initial evaluation 4. It means that it has been very well received, even if that period was very deep crisis in Brazil. One of the aspects of the PPGCosmo is that it's a thematic PhD program involving many institutions in Brazil and abroad. So the name of the program already says that, Astrophysics, Cosmology, and Gravitation. And it's tried to put together many persons working these themes from different institutions. How can I pass, Diana? Okay. And the main motivation I list here, physics and astronomy are demanding for large collaborative network, as we have seen in the previous talks, the 2 previous talks. And it's tried to put the formation of the student as environment and also the research groups to participate together of those different programs in the network spirit, and also trying to put together theoretical research, high-level theoretical research in large observational experimental projects. I do not see, okay. And the thematics include astronomy, astrophysics, astroparticle physics, cosmology, dark energy, dark matter, gravitational waves, and high energy theory. Of course, there are other connected relations here. Please. So in Brazil, it includes the following institutions, research work in the following institutions: Centro Brasileiro de Pesquisa Física, Rio de Janeiro, the University of Juiz de Fora in Minas Gerais, also de Ouro Preto in Minas Gerais, and the University of Bahia, and the Rio Grande do Norte International Center for Theoretical Physics that exists in Natal. And the program is based in Espírito Santo at UFES. So just to give, please. Here is just to show you a picture of UFES. We work mainly in this building. This is Vitória, just to show some pictures, not only text. Okay. But of course, there is the other institutions. And abroad, please, we have here in Brazil the list of members for the moment from UFES, CBPF, and other institutions. And there are research that work in many aspects of the problems, observational, and for example, Martin Mackley is connected with observation, programs observation, Ricardo Strand with gravitational wave, but Valério Marra also, JPS, I'll describe later. And please, and here we have at the moment some main research that are connected with the PPGCosmos. For example, we have Alexei Stravinsky, Russia, David Wands in United Kingdom, Jorge Zanelli in Chile, Pacheco in France, Luca Mendel in Germany, Ruth Durer in Geneva, Scott Doddelson in United States, and Guy in China. So, of course, their institution also participates, the main leaders in the abroad that are in the program. Please. And the idea is that the students follow by advice in Brazil and abroad, and the student must pass some time in the institution of this advice abroad. So the student makes this path around different institutions and working in collaboration with different persons in the other institutions. The test must be connected with scientific comparison, and this also stresses some importance when it's the case of the connection between theory, observation, and experiment. Please. So there is a direct participation of the members in the JPS program, Euclid, DES, and Lig Virgo, and also in order to promote this cooperation, this network, we also organize some events, for example, the Verão Quântico, the School of Cosmology, Zeppelin Batista, Stat Quantistica, that frequently is organized in Italy, in a more event dedicated to students that we call Astrofísica Winter, Inverno Astrofísico. And please, what we thought about this is that, we have a lot of the activity in astrophysics cosmology in Latin America, and mainly in Chile, in Argentina, but also in Brazil also, but the most important facilities are located in Chile and Argentina. And even if the budget mainly comes from Europe and the United States, there is also an important effort of Latin American countries. The previous talk talked about a little about this. And so please, here. However, our impression is that the participation of many Latin American countries in this project is not very, it's below what could be expected. Perhaps in the sense, a graduate program in astrophysics cosmology, informal network, like I have described for the PPGCosmo very briefly, may allow to propagate the formation of Latin American students, also cooperation along the institutions. So the idea is to follow more or less the spirit of PPGCosmo, with the participation of many universities and scientific institutions, different Latin American countries, and with some co-advisors for the students that must be somehow working in different institutions. So this may allow to join these groups and to solidify this network. So please, here. In the same spirit of PPGCosmo, the idea is that the formation of student could be cover theoretical spectral astrophysics cosmology, but with an emphasis on observational experimental formation, so in order to use all these astronomical facilities installed in the continent is a good opportunity, very important opportunity for us. So that's the idea. We have something, a Latin America network. So please, Nancy. So, so the formation of a student is not done only in one institution. So he has an advisor in one institution than another. And also this question of use during these formations, in many cases at least, the structure in astronomy installed, astrophysics and cosmology installed in South America continent that we think that's a very good opportunity to increase the activity of the continent in the sense. So please. So essentially is this, thank you.
Thank you, Julio. Just to remind you that if you have some questions for these 10-minute talks will be at the discussion at the end of all the talks.
Okay.
So the next one is Farinaldo, that will give a report of the Brazilian community on dark matter. Please, Farinaldo.
All right, so can everybody hear me?
Yes.
Yeah, okay, all right. So, so could you pass to the next slide? Okay, so in this very first slide, what I'm trying to show you is give you a bit of perspective of the dark matter community in the country, which is quite young. So I'm young and I've seen its birth basically. And so just to give an idea, for instance, regarding numbers, okay, so to give you a taste of how how young this community is. So between 1990 and 2000, we had 10 papers related to dark matter in any context whatsoever. So including all papers regarding dark matter, we had 10 in 10 years. So I might remind you that in the late 90s, we had the big boom regarding neutrino physics and dark matter was not there yet. So for instance, I would say that after the 2010, then we have a big boom of dark matter physics, which jumped from 75 and now today in the last 4 years, we have 315 papers related to dark matter just in Brazil. These papers are all papers, not just theoretical papers, including experimental papers as well. And in all these years, since the 1990s, we had Brazilians or researchers visiting Brazil who were members of different collaborations, and they are outlined there in the right corner up there. Simple, DES, Z0, DEMIC, all these ones that up there in the corner, right? So many of them were visiting researchers who were leaders in their experiments, and they were visiting Brazil for some reason, for some period. I contacted personally many of them before giving this talk. And just to give an idea, I was there in person when I saw the very first dark matter section in the National Meeting on Particle Physics, which was in 2011. So less than 10 years ago, we had the very first dark matter section in the country. So this field in Brazil is really young. It's not at the same level, I must say, as neutrino physics or astrophysics or cosmology. These are fields which have decades of experience and robustness. This is not the case for the dark matter community yet, okay? So, and I also should emphasize that most of the papers related to dark matter from Brazilian researchers are related somehow to dark energy yet. So they have some modified dark energy models, and they have these coupled dark energy models, and they tie that to dark matter somehow. So then most of the papers of these numbers 315 are related to dark energy at some level. But this trend is changing. So I can even share a slide later on where I show how this trend of dark energy related papers is changing with time. And I've noticed that many of the papers are now really focused on dark matter. Dark matter experiments, there are people really work on dark matter from that UFAS where Julio just presented the talk is people relating to dark formation and dark matter halos. So there are people now focusing on the dark matter problem, not just on the dark sector in a more broad agenda. And for instance, on the Brazilian map, you can see below. So please go back on the Brazilian map. You can see below, yeah, that one. So you can see the institutions which have researchers work on dark matter at some level. I have to say that many of them are not that active on dark matter specifically because they work on dark matter on occasion. So they are not really, as I said, they are not really active on the dark matter field, but active on dark sector, maybe probably dark energy. But it's a growing field. The trend is coming, and we are focusing more and more on dark matter. I see now established groups. Last year, when we had a discussion, Rogério Rosenfeld at the time told me about this Latin America infrastructure program, and I visited about 10 universities in Brazil last year, and I contacted many of the people to know what exactly what they were doing before even we wrote this white paper. I didn't even know we would write a white paper about it, but I visited many of the groups to see exactly what they're doing, to have a more solid statement to give you. And I must say, I'm really confident that it's a growing field in the country. Could you pass to the next slide? I don't have many slides. And for instance, this plot, you can see, for instance, very similar to the one that Diego Restrepo showed, where we have this mass window for dark matter, and these plots below, these lines below where we have Connie, Damick, CMS, Atlas are the ones which have the Brazilian involvement in. And for instance, as I said before, I contact many of the researchers either by email, phone call. So for instance, I do know that the Brazilian involvement in Damick is almost non-existent. So the person who was involved in that was Torres from Rio de Janeiro, and he's not involved at all anymore in these experiments. He's still there for some reasons, but he's not involved in the experiments. So regarding light dark matter searches, Connie does not have in practice a Brazilian involvement. Connie is more related to, as Diego Restrepo explained, not to dark matter specifically speaking, but is this still important to dark matter because as it probes light mediators, which have an impact on the neutrino floor, which again will have an impact on the dark matter searches, especially in the low mass range. And the CMS Atlas, so for instance, as far as I know, I contact many people from Atlas. There is no Brazilian researcher work on dark matter affiliated to Atlas in the entire country. So if there is someone there, please later raise your hand, because I haven't seen anyone working on dark matter related to Atlas. On the CMS side, though, the situation is different. There are few groups, not that many, but few groups in the country work on CMS. I visited some of them already. And the LHCb work on dark matter. I'm not aware. We do know that LHCb is sensitive not to dark matter specifically, but to light mediators or light dark sectors. But I don't know if someone worked on dark matter related to LHCb. But fortunately, on the case of indirect dark matter detection, as we had before, the CMS and AMS not anymore. Okay, so one thing that also Diego should know, we will not be involved in AMS anymore. So the only researcher we had left the country a while ago, so we don't have AMS involvement anymore. The only one we will have now is CTA, and it's quite strong involvement. So I would say the active groups on dark matter. Okay, so I'm not trying to undermine the role of the Brazilians in the experiments, but this is a dark matter related talk. And as far as dark matter is concerned, I'll say that we have 3 active groups or 3 active agendas as far as dark matter is concerned. One is dark side, which we have one group only, headed by Ivone Albuquerque at USP, and CTA, headed by Vito at USP São Carlos, and CMS, and there are different leaders. So we have Tiago and Novaes at IFT and Mercadante. Could you pass to the next slide, please? I'm almost done. So in this plot, you can see really the Brazilian involvement in how we are really playing a role in this dark matter agenda. So in the left plot, you can see the limit from dark side on light mediators. On the x-axis, you see the dark matter mass. In the y-axis, you see the dark matter electron scattering cross section, and that limit you can see for a given mass region. Dark side offers the best bound. So this is a leading field, and I do know for a fact that this limit was really driven by Brazilian researchers. So as I said before, I contacted them personally a while back. So I do know Brazil. That's why I think this red curve should be half green and half yellow to really stand for the Brazilian flag, because we do have a Brazilian involvement on that curve. So that I'm quite proud of that. And also on the right side, you can see this plot where you have these red curves also.
Esse cara é um ídolo. Não tem como não ser. As obras de arte que ele já produziu são inigualáveis. É só entrar no canal e você vai se...
I'm sorry, there was someone with some phone there. These red curves are the best limits from dark side, again, surpassing many of the previous experiments or competing experiments. So this is quite nice. In this case in particular is on the dark matter scattering on nucleon. So one is nucleon scattering cross section, the one is electron scattering, and has been approved already the new phase of dark side, which will feature 20 tons of liquid argon. And as far as I know, there is only one group involved. Unfortunately, I don't know really the reason. Maybe it's funding related, as this is a very large collaboration. It requires lots of money to be involved. And I don't know if there'll be other universities willing to pay the bill to join this endeavor, which I think really is worthwhile. Could you pass to the next slide? Would be my last slide. Again, showing the Brazilian involvement. So for instance, on the left plot, you can see in the bottom curve, which is the black one, which will be the CTA sensitivity to dark matter annihilation cross sections. So as you've seen before today, we have a dark matter halo in our galaxy, and we might expect these dark matter particles to encounter themselves and then produce some gamma rays. These gamma rays can be probed by CTA, and CTA will be the leading observatory in high energy gamma rays for the next decade and beyond. Okay, so as far as dark matter is concerned, CTA is the experiment to be involved in, and we are very happy to be involved in that. We are part of the dark matter group inside CTA. So we were also involved in this limit, which is the best limit in the literature. Okay, so, and on the right side also, we have this a small group, not part of the collaboration, a small group with Brazilian involvement, where we provide in the red curve, and also in the one from CTA, one from the other experiment, which was also mentioned today, will be in the southern hemisphere, where we show also the sensitivity to dark matter annihilation. On the right side, where we have pointed is for dark matter annihilating to BB quarks, and the other ones for WW. But it doesn't matter what I'm saying. Regardless of the channel, CTA will be the best probe for dark matter masses beyond a couple of 100 GeV. And one thing I should say is that, for instance, I'm not really just pushing for this case, but I'm pretty sure that the group were.
Rinaldo, if you can wrap up, please.
Yes, that's the last slide. Just a few sentences. Okay. In the future, we will be leading the field international. I mean, worldwide. We are providing a manuscript where we're showing the limits, the best limits, using CTA to provide the best limits on dark matter models, very popular dark matter models in the literature. And I'm pretty sure the Brazilian group on the CTA side will be one of the key players in the field worldwide. So these are the two main ones. Could you go to the last slide? I'm just gonna finish with one sentence. Yeah, so there's a Brazilian community effort. I will say that the main ones at the moment, which are really leading the country, I mean, in that regard, in that endeavor, are the indirect detection side with CTA and direct detection side with Ivoni's group. On dark side, those are the two main ones. We have very important groups. Many of them you've seen already on CMS, etc. Connie, which is related to dark matter and at some level, endemic, but not much anymore. So this is what I've noticed. That's my message that I'd like you to take home, is that we do need a community effort on dark matter. We have very, very few people compared to all the other fields you're gonna see today, we've seen yesterday, we're gonna see tomorrow. I would say the dark matter is the one that needs most funding and more people engaged on. Otherwise, this field won't survive for much longer unless we have some community effort and people really paying attention to this field, which is a major field outside. So that's all I had to say.
Okay, thank you, Farinaldo. So we'll go to the next speaker, that is Darío Rodrigues from University of Buenos Aires. Please, Darío.
Okay, can you hear me?
Yes.
Okay. Thank you to the organizers for this opportunity and for this forum. In this talk, I will present the first laboratory in Latin America completely dedicated to the research and development based on the Skipper-CCD technology. So we have heard a lot about Skipper, and one of the main features of this technology is its very low directional detection. So this is the reason why the lab, the name of the lab is Lambda, which is the acronym in Spanish for Argentine Laboratory of Measurement with Low Directional Detection and its applications. So this lab will be part of the Experimental Particle Physics Group at the University of Buenos Aires, which is also part of the Atlas collaboration. Next slide, please. So this is possible thanks to a very strong collaboration between the physics department in the University of Buenos Aires and the Fermi Accelerator National Laboratory. It started many years ago. Next, thank you. It started many years ago when our senior researchers went to Fermi Lab as part of their PhD and postdoc programs, and it's continued until today. In particular, during the last years, many of us were working at Fermi Lab on this technology. And something that is very important to say, this is not the only one institution in Argentina with people with the expertise to handle this technology. As Guillermo Moroni mentioned on Monday and also yesterday, in Bahía Blanca and in Bariloche, there are also an effort to push forward this technology here in Argentina and in particular in Latin America. Next slide, please. So I have only one slide about one of the main features of this technology, because you already heard about that during this forum. Top on the left, you have a picture of the complete system with the vacuum chamber, the electronics, which is the old electronics. Right now we have LTA, which is the name of the acquisition electronics completely dedicated to read out and Skipper-CCD. It was developed by people at Fermi and also in Bahía Blanca. This is very important to mention. In this case, one of the main features is what the Skipper-CCD is capable of. If you go right to the bottom right, I have here 4 plots just to figure out which is the main feature. If you have a standard CCD, you are able to measure only only once the charge in each pixel. And if you do that over the whole surface of a CCD, what you get is the histogram that you see in the bottom, where the readout noise is between 2 and 4 electrons. However, the main characteristic of the Skipper-CCD that it's allowed to measure the charge in each pixel as many times as we decide. As a result, we are able to distinguish which pixels are empty, which has only 1, 2, 3 charges, and so on. And this is possible not only in this very low regime. If you go bottom left, you see this histogram where we can distinguish between 1570, 1571, 1572, and so on electron. So there is a large full range where this technology allows us to see how many electrons we have in each pixel. Next slide, please. You have already seen these plots also, but let me point it out again. What is the capability of these detectors? The plot on the left is the result that we published this year from the SENSEI collaboration. SENSEI is a dark matter experiment completely based on the Skipper-CCD technology. And as you can see, SENSEI has the best constraint to light dark matter today. And something which is very important to mention here, that it was obtained by using only few grams of a Skipper. Only few grams must be compared with the 1 ton, for example, of xenon 1 ton experiment. And on the right, this is the prospect we have for Violeta, that is the next generation in reactor neutrino experiment. And this is the plot just to know, or just to mention that we have a sensitivity, we will have a sensitivity enough to see the coherent lasting neutrino-nucleus scattering with 100 grams of this detector in something like a month. We have been already in Atucha, and we have evaluated places where we can install this detector. Something that I want to mention, Guillermo already mentioned yesterday, but let me say one more time, that we are also investigating, which is our sensitivity for new physics beyond the standard model. For example, for neutrino magnetic moments or light vector mediators. And let me say that this looks very, very promising for all the physics that we are aiming to. Next slide, please. So this is probably the most important slide in my talk, because here I try to summarize which are our goals, like laboratory. First, because this lab will be placed at the University of Buenos Aires in the physics department of the University of Buenos Aires, for sure, human resources training is one of our main goals. We have already undergraduate, PhD, and postdocs working on this. And of course, we will encourage to continue with this task. On the right, you see that we will and we are already participating in the data analysis of many international collaboration. SENSEI, as already mentioned, Oscura, the next generation of Skipper-CCD technology aiming to observe or to looking for dark matter, Coney experiment, and Violeta, also with the Skipper-CCD. On the left, you see that we also plan work in research and development in this technology, and it will be done in synergy with the other institutions in Argentina already involved in that. I already mentioned Bahía Blanca and Bariloche. And there are others two goals. One of them is that we would like to be the place with the people to assist to Violeta experiment. We will have the people to be like the pit crew for this big neutrino experiment, because the physics department of the University of Buenos Aires is 100 kilometers away of Atucha 2 reactor. And of course, we will involve in building this experiment and the maintenance of the detector. And another goal, which is already ongoing, is to use this Skipper-CCD technology for quantum imaging experiment, because in the same way that we can count electrons one by one, we can count photons one by one. And this is an amazing feature for the people working on quantum imaging and quantum technologies. So next slide, please. This is my last slide. This is our laboratory space at the physics department. It was dedicated for many years for teaching. It was the teaching lab for electromagnetism, and it will be dedicated for this lab. We plan to have 2 cryo refrigerators because the Skipper-CCD need to be cool, 140 degrees. And of course, turbomolecular pump station, high purity vacuum chambers, and several Skipper-CCD. I said several because depending on which is the application you are looking for example, in quantum imaging, we have some Skipper-CCD intended for quantum imaging, and we have different one for neutrino and dark matter physics. Of course, in synergy with the other lab, we will be using this ultra low redoundance electronic that was designed specifically for this detector. So this is all from my side. Thank you for this time.
Thank you, Dario, for the presentation. So we'll go for the next one, that is Beatriz, talking about the QUBIC project. Please, Beatriz.
Hello, I'm here. Do you hear me?
Yes.
Okay, thank you. Please, Diana, pass fast the slides. Well, as you know, we are talking about the history of the universe. That is the Big Bang expansion. All you know that. We can ask why we need to measure the cosmic, the CMB in right, but next. But we know that there are many things to study there. And in this presentation and in this report, we want to push our attention in the anisotropies and in the polarization modes. Next, since, as you know, we are talking about the first moment of the universe. Diana just mentioned this. We need to solve a kind of puzzle to explain some things about the structure of the universe, the geometry, the isotropic, and why it's isotropic, and why the structures of the universe are like this, and why we don't found cosmic relics. So, the inflation is a convincing theory to explain many of these questions, but we have no direct evidence of it. So in the next, the idea is to study the cosmic background radiation, and the most important predictions of inflation is that above density anisotropies, which are connected to the scalar perturbations of the metric, we have a production of gravitational waves, which are connected with the tensor disturbances. So the idea is try to detect that, and in the next we can see that, next please, that since the first proposal by Gamow in 1948, many experiments were devoted to the study of the CMB. All of us remember the Penzias and Wilson discovery and the new discovery by QUBIC collaboration, and in the last year, the precise measurements made by the Planck satellite. So in the next, we know that we are observing the oldest photons that we can see, and the temperature inhomogeneities at the recombination becomes anisotropies, and we can explain part of the process in the recombination to see how the galaxies were formed. At the moment of the decoupling, we have a scattering, and when this scattering produces some special features that we can see in the next slide, because the photons scattered during recombination present or produce some kind of polarization, and this linear or this polarization, these perturbations in density produce small degrees of polarization in the shape of E-modes. But we also know, next one, that this is not the only phenomena that we can see and we can obtain from the the decoupling, we have two components, the E modes or gradient modes without deviation, and the B modes or rotor modes with deviation. And the E modes may be due to the scalar or tensor perturbations, but the B modes are only due to the tensor perturbations. Next. And in this sense, the fluctuations in density does not generate B modes, but the gravitational waves only produce B modes. So to search this kind of effect in the CMB is our main goal, our achieved. Next. To do that, we need to combine, as Diana just mentioned, to combine all the cosmological observations and try to determine the ratio between tensor and scalar. And as you know, the simplest inflationary model predicts this relationship is 0.01. So this project, the QUBIC project, aims to study the values of this parameter between 0.01 and 0.1. Next one. And we have an important motivation to measure the polarization in the CMB, and we know which kind of spectrum we need to see, we need to determine to prove the existence of this kind of polarization, the B modes. In this sense, next one, we know that the first polarization detection of E modes were performed by Dassey experiment in 2002. And in the next one, we will remember that in 2014, the premature announce of the detection of B modes was the front page in all the newspapers and portals in internet, but this detection, well, the subsequent analysis presented some contribution of the emission of the galactic dust, the polarized emission of a galactic dust, and then the studies on this way continue. So now we have, next one, we have the opportunity to, well, a new impulse to the existing experiments and ongoing experiments, and one of these experiments is QUBIC. Next one. Well, why is it so difficult to measure the B modes? Well, because you need a very sensitive instrument. You need a signal amplitude very short, and extremely sensitive and stable detectors. You need to eliminate the astrophysics foreground. You need to control the systematic effect, and you need a good atmosphere. So in the next, we will present the instrument which is devoted to combine the sensitivity that we need in a bolometric array, and also we hope to control the systematics using interferometric signal. So QUBIC is a bolometer, interferometric bolometer with a polarimeter, and the idea is, well, try to detect this kind of fingerprints of the gravitational waves, the B modes in the CMB. This is a scheme, but I will show you some more precise parts of the instrument. The next one, please. And here you have a design of the complete instrument composed by an external cryostat, and in all in a box, this is the cryostat, not very, very big. As you see, it's 1.6 meters in height, 1.4 in diameter, and just 800 kilograms in weight. The next one. Well, the main characteristics of this instrument is that it's a bolometric interferometer of 400 elements. It's a synthesized imager which can scan the sky under good beam control. Has two bandwidths and 2 focal planes with 150 and 220 gigahertz possibilities of detection, 2 frequencies capabilities, and individual apertures, switchers controlled by horns, which permit the individual reconstruction of the baseline, and self-calibration like...
At least if you can wrap up, please, 1 more minute.
Sorry?
1 more minute, so if you can wrap up, please.
Well, okay, let's go. Very, very quick. The site for the instrument was first Antarctica, now it's Argentina. Next one. Pass quickly, Diana. This is the site in Argentina, in the Puna, with a good atmospheric quality. Next one, with good atmospheric quality and good atmospheric variables. Next one, continue without stop. And next, the first, well, this is the collaboration, as you know, more than 43 members in Argentina. Next one. And a good relationship with other experiments in the country. Next one. Here is the external appearance and the internal, but in the next one after that, continue with my words. You have the complete chain control and cool optics and Kelvin coolers and continue. And the optical filters and next one, and the cryogenic polarization modulator, and next one, please. And all inside the cryostat. And the next one, all just proved in the lab in Paris and calibrated in Paris. Now we are waiting for the instrument, developing the simulation and data analysis. Next one. And a complete software is also developed. And the next one, and the next one. And the calibration will be made in Salta and in the site, which is almost ready to continue to receive the instrument, the mount made in Argentina, ready, well, almost ready. And also the shelter, the next one, the shelter and the dome. And the deployment is ready to be made probably at the end, yes, next one, at the end of this year. And the first light, we hope to have the first light at the end of 2021. Next one. This is the conclusion. We are trying to installate, we're ready to installate this very, very novelty instrument. We developed the site where also will be Shama, and we hope to have a high international impact, and the most important thing, to produce a very good human resources and to establish a good cooperation with other countries, because now the collaboration, as you can see at the first paragraph, is integrated by several countries in Europe and Argentina. Well, I think there is only one more slide, the last one. And it's just to say that you have a technical design report ready and available, and the white paper also available for all. Well, thank you very much.
Thank you, Beatriz. So next one, please, will be given by Carlos about the Bingo telescope. Carlos, please go ahead.
Well, thank you. This is the opening of my talk, and I made a very short presentation as suggested. And I have a few slides after the main slides if we have time to discuss the status, I mean, with the more pictures. So BINGO is an international collaboration between some Brazilian institutions, namely University of São Paulo, INPE, and University Federal of Campina Grande in Paraíba. Next, please. These are the main players in BINGO. So besides the Brazilian institutions, we are leading the project. We have a very strong contribution from Manchester, from University College London, and from Yangzhou University in China. And some smaller contributions from EIS Orsay in France, Université de la República, that was initially in the team. They've been kind of dropping out. ETH Zurich, this Polytechnic, who still contributes with electronics, and University of KwaZulu-Natal in South Africa. So this is 3/5 of a BRICS project. We don't have Russia and we don't have India. And you can visit us at the portal at USP. Next, please. I forgot to say, it's mainly funded by FAPESP, the funding agency of the São Paulo state that's up here, that deserves a specific mention. So our main science goals are measuring the baryonic acoustic oscillations in the radio band. It has not been measured yet in the frequency band that we are aiming to. Actually, it has not been measured in radio. And the idea is to have the 21 centimeter H1 spectrum clearly measured, and that's not complicated, but you have to control the systematics to see the baryon oscillations on top of it. So that's the main goal. We're using a technique that's called intensity mapping, where we don't target specific emitters, but we target the diffuse H1 background. So we cover a very large area in the sky. And the BINGO scan strategy is very interesting to revisit the sky. Every day we see the same patch of the sky. Additional science that comes with that is the life history of hydrogen, specifically in the redshift interval of the most optical surveys, so we can do a direct cross-correlation with them. We can get for free radio recombination lines in our redshift range, and we will have to understand, model, and remove the galactic continuum, which is much, much more intense. One slide back, please. And that's not the main science, but BINGO will be able to get for free detections of fast radio bursts in our frequency band, and that's very interesting because Fabris are a very hot topic in astrophysics today. Next, please. So we have the sky coverage on the left. So BINGO is down left is the red mark, and we are overlapping with the SKA. No, down, left and down, please. So we overlap with Tianlai in China, with FAST in China, and we will overlap with SKA, and we complement CHIME and HIREX in the redshift band. For high redshift, we have COMAP, this carbon monoxide, down here at redshift 2.5, and the HERA for epoch of recombination line, starting at z equals to 5. And we compare the sky resolution. So that's the picture on the right. I included the BINGO. BINGO is mentioned in that paper from Kovacs, but it's not displayed because it was defining the characteristics at the time. So we are pretty much alone in the redshift and angular resolutions that we are measuring. So we're very good because across the redshift in the same angular scale that we measure, we'll be able to overlap with most of the experiments for intensity mapping in the near future. Next, please. Here, we did a quick check with optical surveys that are ongoing, and specifically with the LSST that's coming in the near future. For LST on the top, the BINGO area is the white mark. So we superpose most of the LSST area, and the cut on the right is the galactic center that's removed for both measurements. So bingo, you also remove the galactic area. Just right here. And on the bottom, the bingo superposes with many surveys, S+, with DES, with Atlas. And we are already working on developing cross-correlation tools for to have specific emitters in the optical waveband. And we will check with our intensity mapping coverage. I already wrote to Rosenfeld. Maybe we can start discussing something right now because bingo should start soon. Well, next slide, I'll mention that in a minute. So this is the fiducial telescope information. We work with a system temperature of 70 Kelvin. That's not non-cryogenic instrument, that's room temperature. We have a bandwidth of 280 megahertz, starting at 908 megahertz and going up to 1260 megahertz. That corresponds to a redshift interval of 0.45 and 0.13. We will have 40 channels in this band with a frequency resolution of 7.5. Our sampling time for BAOs is 10 hertz. And the instrument noise down in this table is 26.5 millikelvin in 1 second observation. On the right, that's the fiducial bingo optics. We have a focal length of 63.2 meters. The structure is a cross-dragon configuration, so it's off-axis structure and very compact. But to give you an idea, each of the mirrors, we have 2 mirrors, each of them fits half of a football field. So we are talking of quite large mirrors. The solid angle on the sky is 0.35 teradians, and the resolution is 0.6 40 arc minutes. We will cover about 1/8 of the sky, so the survey area is 5,000, a little bit more than 5,000 square degrees. And we will operate with 30 horns. So the highlights in the bottom. Bingo is a fixed telescope. We have no moving parts. We have fixed wire mesh parabolas and hyperbolas to look at the sky. And we have a transit telescope drifting the sky in front of the instrument. The declination, we will center at -15 declination, which allows for superposition with many optics surveys that are going on in Chile and LSST that will come. And our guiding principle is simplicity. We have most of the things off the shelf. We are building most of the telescope in Brazil, including electronics and everything. Before the COVID-19, we expected to have 1 horn and the dishes installed in Paraíba. That's a site, the site on the left, bottom left. We expect to have it installed by the end of this year, beginning of next year. Now we are a few months behind schedule because of COVID-19. Next one. The management status is we are 80% granted. FAPESP is the main funding agency, and Elsa Abdallah from USP is the general coordinator. I'm one of the main investigators. Luciano Barozzi from USP is the next one. And the construction is ongoing. I mean, the design is defined. We have radio frequency interference measurements working there. We keep monitoring the site to keep it clean from radio pollution. The site is waiting for return to normal conditions to start working cleaning. Actually, we discussed it yesterday, and the road work will start this week. So cleaning and the preparation of the terrain for the structure of the telescope starts this week. We have the horn, transitions, polarizer, magic keys, and the main receiver states already tested and successfully tested. We had a major project review last year. We had a green light to proceed to phase 2, which is the building of the telescope. Status now is antenna. All these components have to be integrated and tested at INPE with no sky measurements, just lab measurements. It will be deployed to Paraíba and it will be tested looking at the sky. The optical design is about to be completed. Engineering processes is under discussions. I mean, regarding costs and the integration of the optics with the rest of the instrument. And this fabrication is in discussion with a Brazilian company that we were really surprised by their capabilities of designing and testing electromagnetic properties of the mirror. Next one. So our challenges. The telescope is large. I mean, we have two dishes that will fit a football field, the two of them. So we are discussing with the company how to produce and how to set them in the position that you saw in the first slide. The horns are large. I mean, they are the largest corrugated horns ever fabricated. So we dominated the process, we dominated the tests, and now we are trying to dominate the costs to fabricate many of them. Calibration stability is being discussed. We use standard calibration methods with COFETs and a continuous wave calibration. But we are trying to develop a way to calibrate all the horns with the one system at once. So it's ongoing at INPE now. Receiver stability has to be tested with internal cooling and under the hot environment in Paraíba. It's the contrary of QUBIC. QUBIC works at a very low temperature. We have to deal with 30 degrees, 35 degrees during winter time, which is Celsius, which is very hot.
Carlos, if you can wrap up, please.
Okay, this is the last slide. The digital backend is ongoing. We have Scarabo, which is the board that SKA is being used. We are starting to program that in the lab. We don't know the learning curve yet, but we are progressing. Optical design is about to be finished. And we are probably the most important thing in terms of management and politics is to define this mobile quiet zone, I mean the radio quiet zone in the bingo area. It's been already requested to the state authorities and to Anatel, which is the Brazilian regulating agency of telecommunications. And we hope that they pay attention to what they request and keep that area a quiet zone yet. So next one. So thank you. And there's some slides, I mean, with the stats of the instrument.
Okay, thank you. Thank you, Carlos. Let's go to the presentation by Rogerio about the LSST.
Thank you, Jorge.
These are some slides of the structure and the project of the horns and everything. So just go ahead.
Yes.
There's some more slides.
Yes. So I'm going to talk about the white paper that we wrote about what's now called the Rubin Observatory Legacy Survey of Space and Time. The name has changed. It was another name, but it was very nice because now the observatory is named after Vera Rubin, which you probably heard about because of the dark matter connection. And the LSST is a huge experiment. It's a flagship experiment. It's a state-of-the-art survey of space and time. And it's separated into many different working groups. Actually, they call science collaborations. And I'm part of this desk, which is the Dark Energy Science Collaboration. It's one of the science collaborations. And people from Brazil are mostly involved in that, but there are also some people involved in other science collaborations looking at solar system objects like trans-Neptunian objects or galaxy evolution, which is, so that the Dark Energy Survey collaboration is mostly concerned with the dark sector, so dark matter and dark energy. So next. Yeah, so this is just a snapshot of projects that are already finished and future projects. And you can see we were already involved in Dark Energy Survey, which is up here on the top. And also I show some of the other projects that we are involved. So next slide, please. So I'm part of this laboratory called LINEA, which is the interinstitutional laboratory for e-astronomy. And this laboratory gives support to Brazilians participating in state-of-the-art cosmological projects like the Dark Energy Survey, the Sloan Digital Sky Survey, the Dark Energy Spectroscopic Instrument, and the LSST. So go next slide, please. And also, just a little bit more about the LSST. It's a 20-year project. it will generate a huge amount of data, 15 terabytes of data per night. And some of this data will pass through Brazil, and then agreement was made with the Brazilian institutions, an agreement that was led by this linear laboratory with the LSST, also signed by some other agencies in Brazil. And in this agreement, you have to pay to be a member of these large collaborations. And this agreement valued the amount, the infrastructure of passing this data through Brazil in $2 million, which is enough to pay for 10 principal investigators working in Brazil. And each of these principal investigators can have 4 people in their teams. So we have 50 people that was working, that were allowed to work. And then there was an open call that was made for the Brazilian community for people to put candidacies to be one of these principal investigators. So we have 10 principal investigators working LSST. Next. So one of the challenges is to, there's a huge amount of data, and we have to be able, we must be able to not only analyze the data, but run Markov chain Monte Carlos and stuff like that. So e-science is a very important step, and I have a few more words to say about that. Next. So there's a recent European initiative, just to throw an idea of ESCAPE. I think I mentioned that. And I think this could be something that this forum can think about, how to provide a infrastructure for computing in the region. So next. And these are just the members that are projects that are members of this European project. So this could be an interesting framework for Latin America. We have to think some more about this. Next, please. I just want to mention that there are some initiatives in Latin America for meetings. I mentioned a few of them. Cosmosur is some workshop that takes place from time to time. I think the last one was 2015. So this is Cosmology and Gravitation in Southern Cone. Next. And this is a workshop that we organized in 2018 in São Paulo. It's a South American workshop on cosmology in the LSST era. It was the first workshop of this type in South America. So I think this is really important to keep in mind. And next. This is another workshop. It's called GRACO. So it's a Reunión Argentina Brasileña de Gravitación, Astrofísica y Cosmología, which was supposed to take place in April in Buenos Aires, but was postponed due to COVID. And next, there's some advertisement I want to make. So we are also organizing in December of this year a Latin American workshop on observational cosmology. So this is organized by Cora Dvorkin, who you may know, is an Argentinian professor in Harvard, Nelson Padilla in Chile, Miguel Quartin in Rio, and myself. Probably we have this as an online activity, so I invite you to participate, of course. And this is my last slide, I think. Let's see, do I have another one? Yes. So I just want to close by saying that we should increase the participation of people in the community in Latin America in cosmological projects. Just to mention that cosmology is also important for dark matter. You probably know that many bounds on dark matter particles come from cosmology. And just to mention that the Dark Energy Survey was the project which I'm part of also was fundamental in finding new dwarf spheroidal galaxies that are rich in dark matter. And there was a joint paper with Fermi trying to find indirect signals of dark matter from these dwarf spheroidal galaxies. Also, LSST has a working group on dark matter, so this is important. So I just want to close by saying that I have a few ideas on how, maybe crazy ideas, on how to increase the cooperation or the participation of Latin American physicists in cosmological projects that are happening in Chile. So maybe in the discussion session, I can talk a little bit more about some crazy ideas. That's
Okay.
all.
Okay, thank you, Rogerio. So let's go for the next talk that will be given by Odilio. It's about the SAGO, the South American Gravitational Wave Observatory. Please, Odilio.
Thank you. I'm going to talk about SAGO, South American Gravitational Wave Observatory. Next slide, please. Gravitational wave astronomy has been a success since the first event detected, GW 150914, in September 14, 2015. 14 events have already been announced, 11 involving binary black holes, 2 involving binary neutron stars, and 1 involving a 23 solar mass black hole and a 2.6 solar mass object, which may be the most massive neutron star ever detected or the smallest black hole ever observed. Next slide, please. One of the most famous of these events was GW 170817, a binary neutron star coalescence which had an electromagnetic counterpart in many energy bands: gamma ray, X-ray, ultraviolet, optical, infrared, and radio, inaugurating a multi-message astronomy with gravitational waves, less than 2 years after the debut of gravitational wave astronomy. GW 170817 marks the beginning of a new era of discovery. Next slide, please. Because of the first detection, which inaugurated gravitational wave astronomy, the 2017 Nobel Prize of Physics was given to 3 leaders of the LIGO project. Next slide, please. The 3 interferometers involved in this observation were these 3. The 4-kilometer arm LIGO Hanford on the top left in Washington State, USA. The 4-kilometer arm LIGO Livingstone in the top right in Louisiana State, USA. And the 3-kilometer arm Virgo in Caccina, close to Pisa, Italy. Next slide, please. Near to join the team, there is the underground Kagura interferometer in Kamioka Mine, 220 kilometers from Tokyo, Japan. Inside the same mountain, X-Mass, Kamiland, and Super Kamiokande are installed. Next slide, please. Kagura will probably join LIGO and Virgo in 2004, scheduled to start by the end of 2021. And LIGO India is a 5th interferometer planned to join GW Search in 2025. In 2001, GW observations were happening once every 2 months. In 2005, it is expected more than 1 event per day from binary coalescence. And of course, they will detect many other events that haven't been detected, other types of events, like supernovas and continuous waves. It's also planned an update version of LIGO Voyager, which will observe many events per day of binaries. Next slide, please. After that, the 4-kilometer arm Cosmic Explorer will be constructed in USA in the 30s, probably, in the next decade. It will be a 3G, 3rd generation interferometer. Next slide, please. The Cosmic Explorer arms are so long that there is a problem to follow Earth's surface curvature. A large amount of money will be spent just to move soil from the construction of a straight line tunnel for the laser beams. Because of this reason, LIGO people are searching for flat land sites in the Middle West of USA. Next slide, please. These are the sites in the Middle West USA. In Idaho, Nevada, Utah, South Dakota. Next slide, please. Another 3G interferometer is the 10-kilometer arm ET Einstein telescope, which will be constructed in Europe. ET will be underground, like Agora. Two sites are candidates disputing the final choice. They are Sardinia, the island, and the three borders site, Netherlands, Belgium, and Germany. Next slide, please. The ET collaboration involves many European countries, a collaboration model that could be followed by the SAGO collaboration. Next slide, please. The 3G Cosmic Explorer and ET will surpass by far the sensitivity of the present long baseline ground interferometers. Thousands of binary GW events will be observed every day. Next slide, please. Then comes the idea of a 3G laser interferometer in South America to be constructed ideally in the same period as Cosmic Explorer or ET. Next slide, please. There are already a few sites with some interesting advantages, quietly seismically and or flat, or scientifically infrastructure already built around, such as the OG site, for example. Next slide, please. One of them is the salar of Uyuni in Bolivia, which is a huge salar, a salt area, flat area, and about 100 kilometers in diameter. Next slide, please. Another one is the dry, flat, and with no rivers Brazilian Irecê region, which is also about 100 kilometers in diameter in Bahia state. Next slide, please. There are about 10 3G interferometer technologies to be mastered, and we need to involve Latin American students and postdocs in these technologies. Next slide, please. Before asking money for a proposal, we need to ask fellowships and research money for creating a critical mass of researchers in Latin America and knowledge on the 3G technology. We need to involve Latin American students and postdocs in the present projects, LIGO, Virgo, Kagura, LIGO India, ET, and Cosmic Explorer, and attract them and foreign postdocs with knowledge on 3G to form groups in Latin America. Next slide, please. Presently, there are already more than 16 Latin Americans involved in some of these laser interferometer projects. Some of them are the following. In the LIGO Scientific Collaboration, LSST, there are 8 in the Brazilian INPE group, 2 in the Ricardo Sturani's group, Marina Neri in the Albert Einstein Institute group in Germany, Claudia Moreno in the US group. In the Virgo collaboration, there are Yara Mello in Italy, Enzo Tapia in the Netherlands, and Edson Santos in Espírito Santo State, Brazil. And in Kagura, there is Fabian Peña in Japan. However, we need many more. We probably will need at least 100 people fully involved in the 3G interferometer technology and data analysis. Otherwise, SAGO won't get funded. Next slide, please. Thank you for your attention.
Okay, thank you, Odilio, for the presentation. So with this, we finish with the presentations given today, and we open the time for discussions. So if anyone have some questions on some for the speakers, it's time to do it now. We can do it by the chat or by the Slack channel that we have. So please, we will hear about it. So you can just request here.
There are some comments on Slack.
on Slack. Oh, let me check that. Well, in the dark matter cosmology gravitational, I am seeing that they were discussing about Farinaldo's talk about the Brazilian group's involvement in the dark matter searches. So they were saying that some institutions, they are already working at the
Yeah, so
UFRJ.
That's, yeah. So during the part of the talks, I was wondering if there was someone from other collider experiments who work on dark matter, and then I was not aware that Murilo, I know him really well.
Yeah.
So you're just saying that Murilo is now started work on dark matter, which is very good news.
Yes. Okay, I see that Tiago have a question here in the chat. So
Hi,
please.
everyone. So in addition to what I put on Slack, I have more of a general comment, I would say, than a question. But one of the reasons that I'm here is that there's a large interest, especially within the astronomical community here in Brazil, and this is mostly who I'm representing in this group. There are a lot of people who work in cosmology, but not necessarily directly participating in projects like the Dark Energy Survey or the LSST, but we do a lot of work as PI projects in larger consortia. So one thing that comes to mind is ESO, and there are a lot of other telescopes. Brazil participates in Gemini and SOAR, for instance. So definitely it's something that interests the Brazilian community, how we plan to participate in these consortia, because this is something that benefits directly a lot of the cosmology researchers in Brazil. They do a lot of observations with their own projects instead of participating in one large survey. The problem is that we try to contact a lot of those people here within the country, and there seems to be very little engagement in people trying to submit white papers for LSFARI, which I find a little worrisome. I'm not sure why that happened. I think people are very pessimistic with respect to funding in the coming years, and they are not sure how this initiative is going to benefit them in any way. So I think this maybe goes to show that we need to reflect on how to reach the community at large. How are we going to convince them that it's important to work as a group to try to bring people to this and make sure that this is something that could benefit everyone? And I'm not sure. I'm just putting this out there, and I'm not sure how to address this.
Okay, so Marcela, if you can.
Yes,
actually, you can lead the discussion, please.
Yes. So first, so going just to answer Tiago, I think that would be super important. It was one of the problems we were facing, is how to reach the communities, and we can try to discuss that also online or offline. Obviously, this group is not going to secure funding, but is hopefully going to give better ammunition to refer to the briefing book that then could help when asking for funding. Of course, for that, people has to be engaged. So I will try to, at least in quotation marks, lead the discussion in the sense that, so Diana, Diego, and I discuss a little bit about how we were thinking what we want to put in the briefing book. And we also discussed with Marta a bit about it. And so we tried to put here something that is not only for cosmology, gravitation, and dark matter, dark sectors, but is more generic. And one of the things that we realized is that, of course, there is a lot of diversity and different approaches between, the neutrinos, the astroparticle physics that is coming, And for example, what was presented today, that was cosmology, gravitation, and dark matter. We already heard clearly from Farinaldo that dark matter is, kind of in its infancy in Latin America. In the amount, not there are a couple of good efforts, but there are just a couple of maybe good efforts, or a few. So I think one thing that we were thinking, if we want to write the briefing book, is that some of the information that is there in the white papers has a lot to do with, the general topic presentation, and then a little bit of the involvement of the groups. For example, what we saw in the case of dark matter, and maybe a bit in cosmology. So we thought about these first things to put them on the table. So to first try to think about either experiments or infrastructures. And of course, this is very connected with, experimentalists doing experiments or connected with infrastructure, but also theorists, because in Latin America, a lot of the efforts are, started from the theory side. Of course, in something like cosmology, the division between theory and experiment is much more diluted, so because it's kind of observational. But we thought that would be very useful for all of us that have to sit down and try to write something for the briefing book, to have your input. And of course, it's not possible to make it right now, but input you can, but I mean, it would be very useful if those, in the particular case, those that are thinking about dark matter, for example, could reach out by email to me and to Diego, for example. So basically to think first about the timeline of the experiment operation, the timeline for the results, and the possible upgrades. And once we have these, which I think would be very important, we're listening here and there, but it's not homogeneous. These experiments are starting in 10 years. In the next slide, that we are not going there, but we try to decide present and near future and long term, and long term is next decade and beyond. So once we have defined which are the experiments that each of you, at least listening, are interested in, and what you think could be given us as input, as I said, some of the input is there in the white papers, but not all, then we can go about what we thought would be the things that really are important for this briefing book, that is really in any given experiment or effort, what is really a Latin American group involvement. And so I think we need to understand better the competitiveness in scientific drivers. And this would be, we saw that, for example, a nice plot from Farinaldo that he showed, and also in the second talk from Dario, there is the sensei plot. But these are, where are, so in order to show to the agencies later on, correct, where are the competitiveness in science driver that is being, led by researchers from the region, from the Latin American region, and in particular for each region. Again, we heard a lot, and I'm using the examples that are most fresh in my mind, which I'm sorry, those are related to Fermila for obvious reasons, but technological innovation. We heard Ettore Secreto talking about Arapuca, and how that, which started in Brazil, is expanding to the region, and it's a technological innovation that clearly has the mark of Brazil and Latin America, and is being extremely valued by the international TUNE collaboration and the international collaborations in the short baseline neutrino experiments. We also saw the other example, and so I just given a couple of examples here. We heard a lot about that, the Skipper-CCDs, and how that technological innovation will be a leader in searching and doing neutrino physics and dark matter, and maybe quantum information technologies. Then the other point that we think is important and was mentioned here and there, in particular, Ettore mentioned that, is the connection with the industry. That, of course, is something that is very welcome at the moment when you want to go to your funding agency, especially in countries like in Latin America, where the interest and the needs of the country may not be in basic science. Then, of course, related to that I just said, for a given experiment, and again, we hear it scattered here and there, the capacity building that these contributions imply by capacity building for students and younger scientists, and not everybody who is a student in a given experiment will, of course, stay in academics, but that is exactly one of the big pluses of what we are doing. And finally, and of course this is not exclusive, if you have other ideas, we are welcome to listen, the leadership opportunities for the region. Again, we heard during the talks, the leadership opportunity for the region and the examples I just mentioned that are, again, we heard, for example, in the past talks about cosmology, the different talks about cosmology, important opportunities of leadership for the region. We also heard it in the part of the Skipper-CCDs is clearly a leadership opportunity. When I say leadership opportunity for the region, is that Latin America could have the could be recognized outside of Latin America as the leaders in a given contribution through their technology or through their personnel, correct? The strong contributions from the scientists. So what we think is that for any of the areas that we want to write about, could be super useful to have this information in black and white, the most you can, and to, basically you can, I think what we were thinking is, who are the conveners of your area of interest. And so just writing, 1 page or 2 per experiment, per contribution, trying to, put the things that each of you think that would be useful to build the case. So of course, the conveners will write some introduction about the science and so on, but then I think what we need is to write what are the science driver, technology innovation, connection with industry, capacity building, and leadership opportunities from the region and for the region. So I would like to ask input before we go directly to dark matter and cosmology, generic input about this, that at least, a few of us thought about this, but I don't think we have passed it through the community in any way. Jorge, please. Jorge?
Yes, Marcela. Yes, Marcela.
Yes.
Thank you. So my point that I want to raise here is ask you first, and maybe others here, about the feeling of the status of dark matter, because it was the promised land 10 years ago. It was invested a lot of millions of dollars pursuing it, and there's no answer. I think the window is closing if it's not closed already. So we are moving towards low mass dark matter. But at some point, if we don't find in a period of time that I don't know how much we're gonna be, that's my question, if how it's perceived that opportunity that maybe we don't find the dark matter over there at Fermilab. What do you think about? Because we are planning here at 10 plus years, and maybe the future it's going down about this topic.
Well, I certainly would be delighted to answer that, and I don't think at all that I think that is the opposite, that we are expanding our horizon a lot, but I see Bruce there, so maybe I am happy to answer that, but maybe someone else, I don't know, Bruce, if it's related to the question or something different, maybe you can, I see a hands up, so I was just trying to.
Okay, so I have two things to say. First, I was impressed by bingo, and my question there is, what is the timeline to have data? When you expect to get barium acoustic oscillation measurements? And the other comment is about this dark matter. Perhaps the mystery of dark matter has already been solved, but only one person on Earth believes that. So I will leave you with that idea. Marcela, Karina, I think heard my talk at the Guadalupe meeting, and I have published 5 papers on the subject. They will say nothing else now because no one believes data. It's not theory, it's detailed measurements that solve the dark matter mystery.
Okay. Okay, so maybe Diana, could you put the second slide of to first? Let me first answer to Jorge. So the second slide of no, not this one. Sorry, the second slide of Diego, the one that has all the regions of dark matter.
So shall I leave the question about bingo for later?
Oh, sorry. I was trying to answer first to Jorge, and then maybe you can answer bingo. Is that okay? Is that a possibility?
It's fine for me.
Okay, thank you. So since Jorge asked before, let me go first with this. So, so Jorge, I think that, well, first of all, the WIMP miracle, in quotation marks, as you see marked there, is not at all close. Of course, we are getting close to the neutrino floor, and therefore there are many ideas to tackle the neutrino floor. I mean, if you remember Carlos' talk on Monday, he saw many regions where the preferred area for this WIMP-like dark matter is actually below the neutrino floor. And so there was a big discussion during the European strategy workshop in Granada last year about new ideas of directional dark matter detection in order to tackle the neutrino floor. So that's one thing for Jorge. Of course, as you see here, we are basically in 80 plus orders of magnitude from black holes to the ZeV region. So we have areas here that, first of all, there are a lot of thermal type of relics that are what is called light dark matter, what is there written as hidden sector dark matter. And that type of dark matter is detection is very, very different from the WIMPs. And so there is a lot of activities today, and there are some of them were mentioned. For example, Sensei at Minus is related to a dark sector that then goes to dark matter. I have to say, I think that the problem of dark matter is a real problem, concrete. We only have seen it gravitational effects, and I think this is one of the biggest next, in my personal opinion, is one of the next biggest problems we need to answer in particle physics and cosmology. And then there is an enormous activity in the area of what is called in this region ultralight dark matter, which includes axions, but has many more options of having, from dark matter that is related to scalar sector, pseudo-scalar sector, vector and pseudo-vector type of dark matter. And so there are a lot of smaller experiments where I think Latin America, because these are not huge experiments. So in the hidden sector dark matter and WIMP dark matter, most of the experiments, not all of them, but most of the experiments are collaborations that are huge investments. And so one has to be part of those collaborations to really have hands-on an experiment. In the ultralight dark matter region, not the QCD axiom maybe, but others, are really a lot of ideas in tabletop experiments, or what we heard from Sensei, for example. So just to wrap up, I think, Jorge, I have no worries that in 10 years from now, if we have not found a sign of dark matter, we'll be working even more than now in trying to solve this mystery. So maybe about bingo, we can hear the answer for that now. I don't see the hands up, but I guess it's somewhere there. Who was going to answer about bingo? Sorry.
Wuensche. I don't know how to pronounce it.
Okay.
I found how to unmute it.
Oh, okay, good.
Okay, so the timeline is sort of delayed by maybe 4 months now due to COVID-19. What we had in January and February of this year were the final optical design and starting of construction of the structure. All the engineering plans were ready. We have a fully operational receiver with transitions on the horn. The horn had a paper accepted, the horn construction testing had a paper accepted in experimental astronomy. It's on archive today, actually by coincidence. And we think that we can have at least one horn, maybe 3 of them, but at least one horn with the full digital backend, with the full correlation receiver. That's what we're going to use. So we have 2 chains of receivers per horn with the digital backend. We expect to have it taking data sometime the next semester, 2021. For the full operation, I do not think we'll have all the horns and all the noise understanding and commissioning before the end of 2022. So I think we can expect a good, if we achieve what we are having in the laboratory, you can expect some BAO measurements by 2023. I'm being sort of realistic because we don't know what to expect with the noise. We know there's a lot to be done, and we have to deal with 30 horns, 40 channels per each horn. They are not an interferometer, so we have to deal with them individually, and we have to calibrate with the same structure all the 30 horns at the beginning. So realistically, I do not think we have a full instrument before the end of 2023, but that's, as a PI, doing with the construction, I'm being realistic, and it can be worse, but it hardly can be much better than that. I hope I answered the question.
Yes, thank you very much, and very, very interesting question. Experiment.
So I would like not to divert from the discussion. So of course, we have to answer questions about the talks. So thank you, Carlos. I was also interested in knowing that. And as you see, it's part of the things that we want to ask. So I would like to listen from you if you think that this is useful, because I think that, in my opinion, and the opinion others I have talked to, we have to sit and write something based on the white papers, but I think we need this type of information to write something that would be useful, and maybe going back to Thiago, that will make people feel that, it makes sense to, it's not just writing a white paper with generics, but is trying to write something that will help the community move forward and eventually also make a case for funding. So I feel it is very important that we get this type of information for the things that we want to push through for the region. So can anyone please tell me if they agree or disagree? And we are thinking to ask this from you in a 2-week period so that we can start collecting, because we are supposed to, we will discuss that on Friday again with the whole group, but we are supposed to have something at the draft level by end of August.
Can I say something here?
Please.
Let me just complement, Tiago, what I was going to say. I not only agree, but I think if Bingo has a funding line with supporters and institutions, which I didn't have time to explain here. If you're going to proceed this way, we still need some funding. But if you are going to proceed writing something that tells the status and the funding needs, I'd be very happy to contribute to that.
Yeah, I think we need that, you know, to make the case. Otherwise, the briefing book would be useless. That's my opinion. So, please, anyone else?
Yeah. So one comment that I would make, and this gets more into the politics of funding for science and how people organize themselves, and going back to what you were saying about coordinating people to participate and make a joint effort to do something about it. I think this slide that's on display here about technological innovation, connection with industry, I think that's very important, because one thing that I feel is a major challenge in astronomy in Brazil, and that certainly translates into cosmology and that mode of observation that I mentioned before, is that people use telescopes in which we pay a little money, but we're minor partners in the telescope, and that is really difficult for any sort of involvement in terms of instrumentation. So we're users of the telescope, we don't pay a lot, but that gives us very little opportunity to develop any kind of instrument for the telescope. And this is something that needs certainly more coordination between the community, because we need to invest more. We need to be bigger partners within the consortium, but at the same time that reverts back to the community when it comes to developing cameras and spectrographs and whatnot in terms of instrumentation for the telescope. So I think this sort of initiative, as far as LSFARI goes, I think it's very important. But again, it's a challenge, because I think the community, at least when it comes to astronomy and cosmology in Brazil, the community seems to be very fragmented. So getting everyone together within a single group that thinks strategically and long-term aspect, it's a challenge. It's definitely difficult. And again, I don't know how to address that mindset. I don't know how to do anything about it.
Well, I think that, of course, you cannot force people to do things, but you can try harder to reach out to make them see that there is some value to this. Maybe they didn't see the value before, and maybe we can try to do an effort to show that there is value by the questions we are asking. I don't know the community the community you are referring to. I don't know it directly, but you are part of this process, and so Tiago would be maybe your hard work to try to get them to. I think we should write exactly what you said. Should be. In part of the summary, that is weaknesses and strength for the different communities that I said. They are different. There are different communities in countries, and there are different communities in topics. But this issue seems super important, and so should be highlighted, in the summary of what we have discussed here, correct? And maybe try to twist a few arms of people that you think that you can't twist, so that they would give you more ammunition and more input. That would be my way to deal with that particular point.
I'll try. I'll think about that, but definitely important. I definitely agree with everything you said.
So anyone else before we move to we have a couple of other slides that are, this is the basics. So I wanted to get your input on these. And this, I think, is useful for all the topics at different level. then we want to go directly to the dark matter and cosmology part. So Diana, maybe, if any, yeah. So here is, now we are trying to make it more direct to cosmology, gravitation, dark matter and their sectors with LA involvement. We try to put here this list that we got from the white papers, but again, please feel free to jump at us and tell us you have forgotten this as is important because of blah, blah, blah. And we would like to have a contact for each of these experiments. And again, as I said, some of the indirect detection experiments will be in the Astro session, but it's okay that we refer in the briefing book, in one part of the briefing book to the other part of the briefing book. That's the nature of what we are doing. Of course, it's interconnected. So we try hard with Diana and Diego to put all these together. As I said, I was thinking to put theory somewhere here. I think theory is everywhere here because it's very intertwined with experiment, especially in Latin America. So we would like to have a point of contact for each of these so that this point of contact can come to us and in the ways that in the ways that we need to answer the questions that we put before. So we will put it somewhere. I hope Rogerio agrees that we'll put this version of the previous slide somewhere in the web page with a link so that people can look at that. And then we would love to have for the cosmology, gravitation, dark matter, and dark sectors, we would like to have a point of contact. So if you who are here today can please try to decide who could be a good point of contact. In some cases, I know who would be a point of contact for dark matter, and maybe Diana or Tiago or knows for cosmology and gravitation. In others, we don't. So I think that, so you who are part of these experiments or theories who are interested in these experiments, please try to contact one of us, attending the experiment, and tell us either if you want to be the contact, point of contact, or if you propose someone who you think would be a good point of contact. Is that reasonable? Someone please answer.
Yes.
That was what, Rogerio? No. Who was that? I'm sorry, I didn't recognize the voice.
It was me, yes.
Ah, okay. Okay, so maybe Diana, we try to, so first look at this, we will put this slide, so if we forgot something, you are welcome to shout at us because we did the best we could. But,
maybe, Marcela, maybe you can also, sorry, maybe you can also use the last free page instead of the workshop page for this.
Yeah. We can, I guess the last free page would be good. So please look at that, and we will try to make a comment with. We will go back to this on Friday, Rogerio, with Marta and you and Xavier. So we'll be together discussing that, correct? So then we have a few. So these are basically building thoughts on how to better, so I will go through them, on how to better answer the questions that we put, or the points that we put in the first slide. So this is like brainstorming a bit more. So we thought about needs and international impact. So first we talk about the needs and the main needs of each of the projects / experiments / infrastructure. Of course, first we say in the most immediate future, but then we are going to look at long term. And this means, in local / LA personnel and expertise. I think we touched that here and there, that we need to build expertise. In many of the talks, it was highlighted how much we need to build some expertise. In the actual infrastructure that may need also, they have needs. And for example, Tiago, you were saying, people have time in telescopes, but there is at little cost, little time and little involvement allowed. So that is a clear need that we should put forward. Hardware and software needs and RRD needs for upgrades. So again, this is a bit for each of the areas could be different. Some of the things will be applicable and some of the things will not be applicable to your own interesting area, but I think it's important. And then, so Ivan, let me finish this piece and then I let you, I see your hand. So what are the needs for international participation in the case, especially that are LA-based experiments, but in general, how much the scientists of the region will need to have international participation in their projects. And then I think what we were saying, what would be the international impact or scientific competitiveness of the project or of the effort made by scientists in the region, in Latin American region, in the next 5 years and the long term. So what would be really the impact that what we have to strategically plan? What would be the international impact of the Latin American scientists in a given project? And then I put here this that I'm not sure that we are ready to discuss this because this is more maybe related directly to cost and maybe is very different and has to be dealt with the different agencies. But this is in the back of my mind when I think about needs. Ivan, please.
Yes, thank you. There is no thumb up to agree with your comment. No, I was wondering in the previous slide if you were talking just about dark matter and today's session on, or it was just because this slide it's just more general, I think. Now this is more directed to gravitation, dark matter, cosmology, and the other one I think it's something more general because you said to discuss it on Friday, so maybe I'll leave it for the Friday session.
So I think that while thinking about what we have to do for cosmology, gravitation, and dark matter, we realized that it was important to put it in a broader context. So this slide that you are looking at is the one that we are putting for our session because this is what we are going to have to write. But the previous slide and the two that are coming, so when I was reading and there is a second part of that, those are generic and we will probably put them back again on Friday, correct? The dark matter part is this one only, and this is for being sure that, this is what we have in mind as Latin American involvement, and I'm sure we are missing things. But so this is for dark matter, gravitation, cosmology. The next two are also generic, Ivan.
Okay, no, because of the things you said on that slide, it seems more general about the involvement of the different experiments.
Yes. Okay. This is
okay. So maybe
slide number two. Slide number 2 is for our groups. Slide 1, 3, and 4 are for the whole effort for anyone who could use that and feel that is the good thing to use to make the contributions for the briefing book. So we are putting it to the whole group of people that are participating. So we have these needs and international impact that I think is something that we should try to elaborate the most we can, because by elaborating, by doing this effort, correct, of elaborating on these, we will also, many times when we ask these questions, we realize what we are missing, what we should be improving in order to then, get the best needs impact and realizing which are the needs that we have. So then the other thing is participation of Latin American scientists. So I think each group and experiment and region should ask, what is or could be. And we heard that from I know Farinaldo left, but we've heard that from him for dark matter and for other areas. So what would be the desired level of investment and participation of Latin American groups to have an impact and recognition in the experiment? And I have seen this, for example, there are small groups of country A, B, or C in Latin America, who, you know, the country is part of the Dune experiment. But when I talk to the Dune spokesperson, they say, yeah, it's great to have 35 countries, but there are, you know, there's nothing that there is a disconnection, and probably it's a disconnection because that group of people do not have the needs covered, correct? Who do not have what they need to really make an impact. So I think we should try to pause and think as much as we can for the different areas, what is and would be the desired level of investment and participation to have recognition within the experiment that are mostly international. So next. So finally, these are a lot of thoughts, I think useful again for general, not only for dark matter or cosmology. Or so impact on Latin American community and neighboring fields. So this is a bit of recapitulation on what was in the first one, in the first slide. I see that Ricardo says that lost connection. Maybe Rogerio, can you take care of? Okay.
He's back in.
Okay, yeah, but no chat history because you lose it. So how will a given project benefit the Latin American community working on related topics? I think that's very important. And the telescope example is a good example, not the only one. How can theorists get more involved with experimental results? I think this is crucial for Latin America because, you know, I'm a theorist, so I understand that, you know, I'm looking at, you know, matter-antimatter asymmetry. I look at my models. My models have extra scalars. The scalars are being searched for at LHC and in other experiments. And it is, for me, of interest to knock the door of the experimentalists and make them pay attention to what I think is interesting. And I think that is one example I have in mind when I say how theories can get more involved with experimental results. In other cases in Latin America, many theories have opened the path for students, young students and postdocs to become part of the experiments. So that's also very important. So how can we, in that sense, benefit future generations of students to get closer to data? How will a project or facility serve to train students and young scientists? Again, participation in experiments. We know experiments, many experiments you have to pay an amount of money to be part. How will LA-based experiments benefit students across LA institutions? And this was thinking about this Latin American graduate student exchange or program or network that was presented by Julio. I mean, I think this is an excellent idea. How can we make it as stronger as possible? So this first part is for, I think, scientist training, students and scientist training. And then these next two go to the knowledge, the transfer and building capabilities. So how do LA-based experiments, projects, facilities contribute to knowledge and technology transfer? And how can the Latin American high energy cosmology, astroparticle impact and benefit society beyond its scientific goals? We always like to say that when you get an MRI, you are using the technology developed for constructing accelerators, and there are many examples of that. So how much we can get from our science beyond scientific goals that are a golden way to convince funding agencies that what we're doing is much more interesting than just basic science if they are not interested in basic science or they think it's not a priority enough. How can we develop more synergies in the region? I think that's important. Which are our connections with neighboring fields? This is related with beyond our own scientific goals. And then I think in boldface, we have put something that we think is very important, how we can identify areas and experiments, projects that could be strengthened per country. And we have some examples that we heard about. And based on the strengths and weaknesses of our Latin American programs, what are or should be the scientific priorities of the region for the next decade? So the last two are more, strategic and future thinking, but I think they are super important. So I would like again to have, we will ask for contributions, and we will have to see how we arrange these contributions. But I was thinking to rearrange it per conveners of the different topics for people to give succinct, clear, and if possible, coordinated input per experiment or per group in some ways, because we can really deal with everything, so that we get your thoughts about these. And again, this is all going to the slide number 1. And I hope we come back to this on Friday. And so I would like to listen any comments you may have. Please feel free to comment, either if you agree or disagree.
Yes, Marcela.
Yeah.
I think the point that it's with bold letters there is very important, because every country have their own, let's say, history and idiocracy and idiosyncrasy, and also their own problems, or what its main focus in. So the thing will be how to try to converge to something, or we want to converge to something, or we will still, we will choose 2 or 3 topics of main interest for everybody, according to.
Well, you know, I think that my hope would be that we emerge with, you know, after looking at the input, that we emerge with some leading topics that we think are the most important for the next decade, correct? This is the first of these exercises, and I hope not the last one, correct? And, you know, the European community, the US, Canada, they do it every 5 years, okay? And they revise what is there. So this is our very first one, and I'm sure will be a million things to improve upon. But we need to start from somewhere. So I think that at this moment, anything that is brought that is of sufficient interest to a group of people would be considered by the conveners. That's my best answer, Jorge.
Yes, it's okay. I think we have to discuss that on Friday.
Yeah, but that's why I wanted to put it today, so that people have time to look at it, think about, you know, think about a bit carefully, and then come with. I would appreciate that whoever comes with ideas, comments, and so on, please try to think that has to be. Even if it is a criticism, has to be a constructive criticism, and succinct, so that we can get something, you know, get the core out of whatever is being proposed. Or you know, my idea was to look at these things for each of the efforts, per effort, and so each of the conveners, we have to deal with efforts in their area.
Oh, Marcela, I mean, many of these things, as you know, were the kind of the guidelines that were sent to the conveners for each one of the topics to identify precisely with the input of the white papers. But I think you're making a very important point in that the white papers contain some information, but there's some crucial information which is lacking, which needs to be obtained to be able to make a much more convincing argument of the scientific merit in some of the cases of what was presented. And what we're interested in understanding for each one of the subtopics is precisely which is the most competitive scientific merit of each one of the proposals or white papers or experiments that were presented, understand what are the main competencies that they have in terms of instrumentation or software or computing or whatever, and the main challenges associated. And it fits into all these other topics that you're also building up here. So I think that we're all kind of trying to put this, you know, puzzle together, but we need to be able to get the information that will really clarify in some of the cases, that what is the scientific merit and for how long?
Yeah, I think that's what I'm saying. I think in some cases, probably this information is in white papers. For the dark matter, well, maybe because it's very, it's the ones I have looked at, dark matter and dark sectors, I have looked the most. You know, for example, tomorrow we will hear about the theory part of the Colombian effort, and they have basically a huge part is a dark matter report, but I think these questions are not answered in that part, and so we would need, you know, it's a theoretical effort mainly, but still, it's something that in order, so they have this, as you know, Marta, there is this MOCA, Materia Oscura in Colombia, and there's an excellent effort that has started, but we need to have a bit more of, focus, planning and evaluation of which are the strengths, which are the possible contributions for now and for the future. So I think if we don't get that information, it will be very hard for the conveners. You know, I cannot find out exactly, for example, what's shown, you know, what dark side, what was part of the dark side contribution from Brazil, and in particular, you know, I wouldn't know that, correct? I mean, unless it is presented to me as a convener. And I think that is the case for many. So I think it is in the own interest of those who wrote the white papers and maybe trying to get those who have didn't try to contribute as well, to answer these questions so that we can do the best job we can for the briefing book, so that the briefing book is useful.
Okay. Marcela, I think you made very interesting points, and we have a lot of information to think about and discuss on Friday.
Good.
So these slides are available and people can take a look, and then I think we should discuss exactly. I think the best thing would be just to send this question directly to the person that wrote the, or a point person, as you said, from experiment or from the papers. And this person will be responsible to collect information for the preparatory group. So can we wrap up?
Yes, I am open to whoever wants to say something. I am totally done with what I wanted to convey. Yeah, and it's not only me, it's Diana, Diego, and you know, I have talked to some of you, but not to all of you in the past few days.
Okay, I don't see any hands up or any urgent. Yes, Maximo wants to ask a question. So Maximo, go ahead.
Yes, this is just a comment. When choosing like a project to develop, there's like a balance between scientific merit and also like the know-how that you built in Latin America. For example, if you want to build a top detector that will have a great scientific merit, but you have, but you will, the detector itself will be built in the US or in the Europe, I think that might not help for developing future detectors. So the only thing I want to say is that there's a balance between scientific merit and also what can be built here.
Yeah. Sorry, Marta, go ahead.
No, I mean, I think your point is really well taken. I think it's one of the issues that we really want to identify when we characterize the different initiatives, of which of them are really capacity building efforts that will enhance further down the road our ability to be able to, you know, take on the more and more responsibility in significant experiments.
I would just say very briefly that my experience is with Brazil and Peru. And I think, you know, when talking to the funding agencies, it's so important to say, you know, we're asking you this money not to be, you know, not to be sent as a contribution to build a piece of a detector in the US, okay, let's say in this particular case that we were talking about June, but to, you know, to open an electronic lab or a lab in your country, in your universities, with your people, training the students. And I think that should be, for Latin America, I think a priority. Of course, you can't always do that, but you know, things are so complex these days that you always have the opportunity to contribute concretely with something that you can build. And all these big detectors and machines are done in pieces. I think Davis is trying to say something.
Yes, thank
Please.
you. So yes, I just want to mention that, well, yesterday I made this presentation related with the Dune Colombia first. And I think that this topic, I think fits very well with what already said. I mean, we have the experience with this development of the Daphne board. So that was something that I wanted to present yesterday, but probably the message was diluted between the different talks that we had yesterday. But I think that the experience with that development of the Daphne board is that we are now working together with Fermilab, and but at the same time we are developing some tools that actually in Colombia, more than tools, I will say, it's better to say knowledge that before was in our institutions, because we have a lack of tools for the design, and also actually the need or try to learn something, because in the local industry or in the local universities are not under consideration, because it's something that is not relevant. So I think what we are doing now, I mean, I have, of course, some bias because I am working on Dune. And of course, I think that Dune is very important in that sense, because we are trying to collect different institutions in Latin America. I presented yesterday that we are working actually with Peruvian collaborators, with Jorge's group. Yes, so I think that regionally is something that is having a lot of momentum right now. We are demonstrating that we can do that, something that at the beginning was not so clear that we can have the responsibility. We are getting the responsibility, and we want to, of course, have more and more responsibility on, as you say, one part of the experiment. No, we are talking of a big experiment. Of course, the experiment will be settled in the US, but the idea that we have is try to be responsible for one of the pieces of the detector. And as you mentioned before, the idea is in the center of everything when we need to go to the funding agency, because that is the point actually. We need to demonstrate that we have, of course, the knowledge, but that we have the possibility to make the transfer of that knowledge to the industry. No, I mean, this is the most important part for get the funding. So, I mean, I have seen so many different topics yesterday, today. So, of course, we want to do physics, yes? But something that we need to find is the technology that is able to be useful for each of these physics areas. So as you mentioned, for example, if we can see that photon detection in general is something that we can apply for different areas, transversal areas, but this is something that I think we need to try to implement and develop in different countries and making different aspects. Each country has different capabilities, as Jorge said, and each country has different realities, of course. But I think we need to try to find this transversal type of technology, transversal type of element that can be something strong in Latin America and be useful for all of us. I mean, we are all presenting what we want to do, yes, but probably what we need to find is the tool that is common for all the countries, for all the universities, for all the studies, in order to strong that and make a diversification between the countries that are collaborating in different experiments, because there are many topics or subjects that are under consideration. I mean, that is what I want to say.
I agree. I think we need to find these common areas, and so the idea is that you bring it to us, the conveners, correct?
Yeah, so if I understand, Marcela, you want some feedback on these pages that you wrote, right?
We want some feedback. We want a discussion on Friday when we are all of us together discussing. And then we really want to have feedback within 2 weeks. I mean, if you really think about these things, you need some time to think, but you don't need to go for a year to think about these things, correct?
Yeah.
We need to move on, and we will try to get the best we can from all the feedback. And I think we can discuss on Friday how we organize that feedback.
Can I make just a quick suggestion? If you put these pages on a Google Doc or something that people can edit and comment, or...
That is Diego is going to do that. Is that right, Diego? Diego, are you there or you left?
He's here. But...
I don't see him.
Yeah, I see him here.
Yeah, Diego is here. Anyways, I think that's something.
I will send him a message in case he's distracted.
Yeah, I think that can be useful, so people can go and edit and make comments and stuff.
We created this that way in the Google Doc.
Okay, so just share.
Okay, Diego, so maybe you can, where do we put the link to the Google Doc?
In the Slack channel.
In the Slack channel, okay. So Diego, can you do that, please?
Yes, of course.
Thank you, great.
I see Claudio has a hand up, but it's really late. Claudio, is this
Claudio, go, yes, he's pressing.
Okay.
This is a very brief comment.
I don't know what it is, but it's pressing.
About this, impact on industry, I see two ways. One is that you get from the scientific community, you get new technological challenges to the existing industry. That's one thing. That requires a country that has a lot of industry already. And the other one is that you form scientists or professionals with scientific background and technical background, that they get into new entrepreneurships. Those are the two ways that I see.
Mm-hmm.
And this is probably, the second one is probably a very important thing for our countries, where you have to form a new, community of professionals, technicians.
Yeah. Yeah, so putting all these things, I think everyone has to think about their